So an inscribed angle, it's an angle, not surprising, it's an angle whose vertex is on the circle. So I'm looking up here, like angle C is inscribed. Vertex on the circle and its segment lengths, okay, are the sides of the angle are chords. So the sides of the angle are chords. We call the intercept, the arc that it goes to, the arc that it intercepts, the intercepted arc. So arc with endpoints as the size of the inscribed angle. So there's an intercepted arc, simply the arc that it goes to. Okay, something I want to tell you too, sometimes you might see this word sub 10. That means the arc across from an angle. So I might say the arc subtended by angle C. And that means arc AB. So that kind of goes along with intercepted, just the arc across from an angle. All right, now that's what an inscribed angle is. There is one main property. That's it. And it leads to all these little theorems, these corollaries. One main theorem. The measure of an inscribed angle is half the arc. Half its intercepted arc. So first, let's review. Central angles are the same. So like if this is 40, this is 40. So if it's coming from the center, it's the same measure. If the vertex though is on the circle, it's half the arc. So if this angle, if this arc is 20, then that angle would be 10. And it works the other direction, that if the angle is 10, you can find the arc is double. Now, I say one other thing, one note is, let me draw this. If I have a circle and I have one chord, but instead of the other side of my inscribed angle being a chord, if I have a tangent, okay, so I have a tangent, you can also use the inscribed angle theorem. So this is not purely, so this angle right here is not purely, it's not an inscribed angle, but the theorem would still work. So for example, if this arc is 80, then that angle was inscribed. Well, it's not inscribed, but the theorem still holds true. It's half of 80. So when there's a proof of this theorem, there's actually 3 parts to it, 3 scenarios. I can show you the one scenario. So like I can't show you very well if the inscribed angle is like that, but if one of the chords is a diameter, I can show you why it works. So let's look at this one. Suppose angle AOC is 40. Okay. Then this arc would also be 40, right? Central angle. I can actually find, so here's my inscribed angle right there. I can actually find that by looking at this triangle. So these are both radii of the triangle, and they're congruent. We saw an example like this for finding the measures. This was yesterday, actually. I can subtract 40 from 180 and get 140 for that angle. And then in this purple triangle, x and x, these are both the same because this is isosceles. And so there's 40 degrees left between the x's, and I can divide by 2, and I get that as 20. And so what I just showed there is, yes, it's half of the intercepted arc. Now there are 2 other cases, and they're a little complex, so for our purposes, let's just say all cases, the angle is half the arc. Okay, that's the main theorem, and then there's 3 properties that are based on that theorem that we call corollaries. Any initial thoughts or questions? All right, so let's, we're going to do 3 examples that each one leads to the corollary. All right, so we're going to use inscribed angle theorem on all of these. Find the measure of angle 2. So angle 2 right here. By the way, you'll probably notice how I like to outline them. Sometimes there'll be a lot of segments in the triangle and then circles. Now, if you outline them a little bit, it can help you see which arc, which angles go together. So angle 2 is inscribed. The intercepted arc is this arc. So angle 2 will be half of that arc. Now, I don't have it right now, but we see how there's this angle here, the 38. So what's this going to be?
Half 30. No.
Opposite direction. Double 38, because the angle is already half the arc. Right, so the arc is double the angle.
76.
So I double it at 76. Yeah, I don't know why this is here. We don't actually need that. So I doubled the 38 to get 76, because 38 was an inscribed angle. And then angle 2 is half of the 76, so it's 38. So what we can notice is that we have two inscribed angles. They both went to the same arc. So they're both going to be half of that same arc, right? Half of arc. And so what we notice is they will always be the same measure. And this is the first corollary. Two, or actually any number of inscribed angles that intersect the same arc. So they both went to the 76. They are going to be congruent. Now I have one other part to this. I put or congruent arcs. So that means is if I have a different circle, I could have a different circle, and if I know this is 76, well, this angle is also going to be 38. So as long as they intercept congruent arcs, 76, same. And they'll be congruent. Or over here, guys, watch this. I can draw on any intercepted or any inscribed angle that goes to that arc. That's 38. This one's 38. That one's 38. Any of them are going to be half of 76. Okay, corollary 1. Good with that one. See, all of them are the same theorem. This is a good one. The next corollary, let's solve and circle O for angle A. So angle A is inscribed. Vertex is on the circle, made up of two chords for the sides. So it's going to be half of that arc. Using the inscribed angle width theorem, half of that arc. Arc BDC. What's the measure of arc BDC? Yeah?
So it's the angle.
I think
It's the angle that's going to be opposite from it that we're trying to get.
no, we're trying to find the angle A itself, but then we have to use the opposite arc.
So the one that's across from it.
Mm-hmm. The intercepted arc. Yes, I heard it under 180. It's a semicircle, right? Since I know a circle O, that means this is a diameter, so arc BDC is a semicircle. And that measures 180, and so it's 90. So what we find is that if you have any inscribed angle that goes to a semicircle, it's always going to be a right angle. It's always going to be 90. So angle A there. So again, what I could do is I could pick any point on here as long as my chords go to points B and C, making it half of the semicircle. It's going to be a right angle. All right, so then what you could do is I got a problem where then there's like sides and you'd have to like drag your theorem. Yeah, but any of these, as long as they go to B and C, it's a right angle. That's a good one. One more corollary. This one, I guarantee, will be they've released several questions on this for an OST. So this will definitely be a question. And it should be, honestly, one of the simpler ones. Find the measures of angle A, B, C, and D. So we're going to do that, and it will lead us to a conclusion about some of the angles here. I'm going to do angle A, and then I'll just ask that you finish up with B, C, and D. So we have an inscribed quadrilateral. This is from yesterday. All the vertices of that quadrilateral touch the circle. So it's inscribed. To find the measure of angle A, well, A is an inscribed angle. So it's going to be half of the arc that it subtends, the arc that it intercepts. Half of 190. Yeah, when I got to add those two. So 190. And so, yeah, 95. So do me a favor. find B and C and D in a similar way. And then after you do that, you should be able to fill in this corollary. I just want you to find them and then look at what you find. And there will be a conclusion that we can make.
It's a quadrilateral, so that makes sense.
Yeah. So let's keep going here. Help me out with B. What did you get for the final? Wait, B. Oh, okay, I heard somebody say that. B. Oh, that's why. Okay, I was like, okay. So it's half of 154.
Oh, I did it.
Let's see, because B goes to the 64 and the 90. Nice. C, what is it? Half of 170. Let's see, because C goes to 106 and 64, and that's 170. And finally, D. Yeah. Because D goes to 106 and 100, that's 206. Therefore, there's this corollary we can write in. The opposite angles of a quadrilateral, an inscribed quadrilateral, are blank. And we can look at A and C, or B and D, and you should notice that the angles are what? Supplementary. Thank you. Supplementary. Sum to 180. Very nice. Yeah, so honestly, you'll see, I'm going to ask you this, you'll see this. I mean, it seems like OST is going to ask you this for sure. They've given some release questions where, like, they'll only give you one angle. They'll just say, like, here, C is 100, 100. And then they'll say, what's A? And you should just say it's 80. Subtract from, see, so they won't even give you B and D or some other arcs. You just gotta subtract from 180. Okay, as long as it's inscribed. Now, please make sure not to confuse this with quadrilaterals that are not in a circle. So like a parallelogram, not in a circle. Opposite angles are congruent. Yeah. But if it's in a circle, not a parallelogram, just any quadrilateral, it could be like that. The opposite ones are now supplementary. So make sure to differentiate between those. Okay. Last thing I want to do with this theorem on this page is show this theorem is why this is true. So we are going to prove this one. This one, I believe, is one that state says, here, know this one. This is a theorem to know how to prove. Even if not, this is a good theorem to know. It actually comes together nicely. You'll see how we do it, but it's a good one to know how to prove. So what I'm going to do, I'm going to draw a picture here of just similar to before, A, B, C, and D. Okay. And what we're going to show is given that quadrilateral inscribed in the circle. We're going to show that A and C are supplementary, the opposite ones, and B and D also. Now, I did earlier, just to save time, I'm just going to do one pair. It would take us about 3 extra steps to get them B and D, but we'll just stick with one pair. So let's do a 2-column proof. I'm going to set up statements and reasons. So that's given, just the quadrilateral is inscribed. We're going to show A and C are supplementary. Okay. We have no numbers, nothing else we can do except we know the inscribed angle theorem that we learned about. So A is inscribed, right? An inscribed angle. So I can write down that the measure of angle A is half its intercepted arc. measure of angle A is half. The arc that it goes to is BCD. Now, by the way, I will not know, based on the diagram, if it's a minor or major arc. I'm just going to list them all as major arcs. So I'm just going to write, oh, I need M, half the measure of arc BCD. So it may be very well that it's actually arc BD, like a minor arc. But let's just, I'm going to write them all as major arcs for today. And I also know C, so same step here. Measure angle C is half the measure of its intersected arc. And C goes to arc BAD. Okay, or let's write BAD. Okay, that's the inscribed angle theorem. The inscribed angle is half the arc. Inscribed angle theorem. Okay, so we have A and C now, and they're half their corresponding intersected arcs. Here's what I want. Measure of angle A plus measure of angle C is 180, because then they'd be supplementary. So let's get A and C together. So what I'm going to do is simply add these two equations here. So I'm going to add to this one angle C. So the left side of this equation will say measure of angle A plus measure of angle C. On the right side, I'm going to add an equal thing to C, which is half the measure of arc BAD. So basically the left sides come together and the right sides come together. I'm just adding each of those together. So I'll have half the measure of arc BCD plus half the measure of arc BAD. I did add the same, they appear different, but I actually had the same value, an equivalent value to both sides. So this is addition.
So why didn't you add the halves, the one half M together to cancel them out, or to get one M?
Oh, these aren't equal. It's not like half x plus half x.
Okay.
That would be 1x. Yeah, these arcs are different. Good question though. Go back. Okay, so I'm just adding the left side, adding the right side. I got one equation now. Now this is starting to look pretty good, right? Because I want measure A plus C equals 180. So I like it. Next thing is on the right side. Don't they both have something in common? The 1/2. Okay. So I'm going to factor that out. Let's do a GCF. So the left side is going to stay the same. Measure A plus measure of angle C. Right side, I'm just factoring out a GCF of 1/2. So I'll be left with the measure of arc BCD plus the measure of arc BAD. This is a good review. Back from Unit 1. What property is that? GCF, when you're factoring something out. What did she say? Distribution. Because there is no like GCF property. There's no factoring property. But the opposite of GCF would be distributing in the 1/2. And so we use distributive going both directions. Yeah, so it's distributive property. Okay, so we're still getting there. The left side is good. We see the right side to say 180. Now we have half here. So really what I need is I would like this to be 360. Right? Because if that's 360, then half of 360 is 180. Agreed? So let's look at the arcs. Watch this. Arc BCD is, well, I'm going to put it in green. Arc BCD is that one, right? Yeah, I'm actually start over. BCD is right there. Arc BAD is right there. It's a full circle.
180 plus 180 equals 360.
Well, I don't know it's 180. I know it's.
You don't know it's 180.
I don't. But we know together they sum to 360.
But,
Because it could be like
so
this.
you don't know that that's half of the circle.
Right. It could be like. could be like this arc is like 250 or something, and this arc is 110. But we do know that they sum to 180. Or 360. Sorry. Alright, so what I'm going to do is I'm going to take a step and just say that these are 360. So the measure of arc BCD plus the measure of arc BAB, so those together sum 360. And it's simply because it makes a full circle. Let's see, I'm going to write that the, what did I write here? I have it nicely written here. The sum of the arc measures in a circle is 360. So I put the sum of arc measures in a circle equal 360. There's no like rule or property. Just we know that all the angles or arcs in a circle must sum to a 360 total. Okay, now it's just a little substitution, plugging things in and simplifying. So I'm now taking this 360 and putting it in for that. So I got the measure of angle A plus the measure of angle C equals half, and then putting in the 360. And so plugging in substitution. Substitution property. 8 steps, by the way. So finally, I'm just going to put half 360, and that's 180. So measure of angle A plus measure of angle C equals 180. What about that? What property just simplifies that?
Substitution.
Substitution. Addition, subtraction, multiplication, division, you have to do it both sides. So we didn't actually multiply both sides by half. But every time you simplify, it's just substitution. Yeah, that's actually I really like doing this one because we reviewed like a GCF property, addition, and simplifying and substitution. Okay, and finally, this is the definition of supplementary. Two angles sum to 180. So we can say that angle A and angle C are supplementary angles.
What about B and D?
I'm just going to do A and C. I'll tell you in a second what those are. What's the reason I read here? It's a vocab word definition of supplementary angles. Huh? Yep. Sure. Let's see. So So definition of supplementary. So we started with the inscribed angle theorem. This angle is half the arc. C is half the arc. We added them, factored out a half, and then we're able to plug in 360, and it works out. Now, if you want, I'm just going to stop there. But if you want to do B and D, I guess there's a couple ways to do it, but I would have just said A plus B plus C plus D equals 360, and then we could plug in A plus C as 180, and then subtract 180. You got B and D being 180. So it'd be 3 extra steps. I'm just going to stop here, though. All right, I'd like to do 2 more examples on the back to finish up. Any thoughts on this theorem, though? So on the back side, flip it over. I'm going to do examples 2 and 4. I'm going to skip 3. I think what we have with 2 and 4 will really suffice. This is a good one. So example 2, find the value of the variable. So we're going to find A, B, C, and D. First of all, we do have an inscribed quadrilateral, right? So it's the property from the last theorem. We know opposite angles, such as A, are going to be supplementary with the 108. So I can subtract from 180 the 108 and 172. And the same for B, subtract from 92 from 180 and get 88. You also got to subtract these 3 from 360. I'm going to need to clear that off, so just make sure you have down though A and B, the 72 and 88. Okay, let's go to C next. Now C, here's what's interesting. There's no direct angle to C. So we're going to have to find another way, kind of an indirect way. I'm going to look at the 108. The 108 at least goes to part of C. So the 108 goes to this whole angle, but at least it has C in there. Done? Well, I can't find C directly, but I can get the entire purple arc there. Because I have the angle, so the arc is double. Since an inscribed angle is half. So multiply by 2, and I can get this whole arc here is 216. All right, inscribe, and then you subtract. So the angle is half the arc, so we can double the angle of the arc. And we just don't want the 114 part because we're finding C. And so we can subtract, looks like plus, it's minus 114. 102, right? So I really like that. It's an indirect way to get to what we wanted. I'm going to clear it off again, but we're going to do the same thing for B. So I'm going to clear it off here. For B, it's inscribed to the C and the D. We just found this was 102. Sorry. We're finding D here. By the way, I could have tried to use A, because A does incorporate D, but we don't have this arc. So A is actually not going to work. We have to stick with B. All right, so B goes to this arc. B was 88, right? So B was 88. So we can double that. We get that this whole arc in red is 176. And then you get D.
74.
So 74. We'll subtract off the 102.
Did you get the 2 angles on the inside? Yes.
The last theorem. That
What we just did?
inscribed quadrilateral, the opposite angles are supplementary. So you subtract this from 180.
Oh, gosh.
Okay. So that's a good one. Indirectly finding what we want. How about any questions now before I do one more? I'm going to do example 4 to finish up. Let me make a quick picture of this one. We got a similar setup. Quad A, B, C, D. Wow, thank you. I guess you're right. That was quite good. Ooh, it's pretty good except for there. Working on my circles. Let's see. So they give us arc ABC as 140. And they say find angle ABC. They say find this angle. So actually there's 2 ways to do it. I was working this one earlier. I did one method. Another student did another method, and I was like, wow, your method's easier. So what's one way?
So you can find the angle measure.
For D is half of 140.
Yeah, so it's 70, and then that's minus 180.
And then these are opposite because they are inscribed, so it's 110. Yeah. What I did, another way to do it, what I did earlier is I saw 110 is inscribed, and so I subtracted 360 by 140. Got that this is 220, and then 110 is half, or well, angle ABC is half of 220. I think what you did is easier. Okay.